Okay guys, we're kind of starting to review for our test, which is on Tuesday. So I'm going to go over this first problem here, and then you're going to do the second. It says, name the properties that were used to solve this equation. So when you look at something like this, you're going to pretend like you're solving it normally. So I'm going to draw the river, and they want to know what somebody did to get from here to here if they were solving. If you ignore this part, look at this equation. What would we have done first? Where our variable is over here, right? So we would have used addition and subtraction to get rid of this positive 12. If I subtract 12 from both sides, I get rid of this and I only have negative 3x, and then negative 3 minus 12 is negative 15. So the property that must have been used, if we look here, was the subtraction property of equality. It's a property of equality because it happens on both sides of the equal signs. Okay, so next we have this. So let's think about how we would have solved this. We have a negative 3 and an x being multiplied. I know I want to get 1x. So I would have divided by negative 3 to undo the multiplication. So if we check, negative 3 divided by negative 3 is positive 1x, and negative 15 divided by negative 3 is positive 5. So here was your final solution, and we got there by not subtracting. Notice we were dividing. So that would have been the division property of equality. All right, okay, so this one is yours. It says name the properties that were used. Go ahead and draw your river. And I want you to think about how they would have gotten from here to here. They got rid of this negative 7. I want you to think about how that happened and what would have happened on both sides. And then here, they took this multiplication of 5 and m and got to 1m. How did they undo that multiplication? And you're going to write that here. So pause the video and finish that. All right, the next thing we're doing is we're looking at this problem. I'm going to do this one for you. It says substitute the value 5 into the equation for x to determine if it makes the equation true. So guys, anything that makes the equation true is a solution. When we have been solving, right, whenever we solve an equation, we get 3x equals 12. We divide by 3, we get x equals 4. This solution makes the equation true. Watch, I'm going to substitute it in. 3 times 4, I put it in for x, equals 12. 3 times 4 is 12. 12 equals 12. That's a true statement. So that's how we check solutions. So I'm going to substitute 5 everywhere I see an x. So I have 4 parentheses 5 instead of x minus 3 equals 5 plus 3. And then the way I'm going to check this is I'm going to type this side into my calculator. 4 times 5 minus 3 in parentheses equals 8. So the only way 5 is a solution is if this other side is also 8. And we do know that 5 plus 3 is 8. That's a true statement. So 5 is the solution. All right. Now you are going to the back of this page, and you are going to do the same thing with this equation, except for you're going to substitute the value negative 3. So here's our x that we are substituting for, and you want to make sure that you replace the x everywhere you see. Remember that 4 and x are being multiplied, so this side of the equation should be 4 parentheses negative 3, so that you can show that they're being multiplied, minus 17. Do the same on this side, and then you need to see what this equals in your calculator and what this equals in your calculator. If they equal the same thing, then it's a solution. So pause the video and work on that. Okay. Next thing is we're going to go over some things for today. So sometimes equations don't only have one solution. So what we have been solving so far only has one solution. So for instance here we would divide by 4, x equals 3. There's only one solution, it's 3. Actually, sometimes equations are true for all real numbers. And I'm going to show you how that might happen. Okay, so I want you to write this equation down. 5 times x plus 2 equals 5x plus 10. So I'm going to start trying to solve this like we would normally solve. So first I would distribute, right, and I would get 5x plus 10 equals 5x plus 10. I want you to notice that at this point the sides are exactly the same, okay? And that tells us something's going to happen. Now next thing Ms. Gertzen would tell you to do if there's variables on both sides is to subtract 5x and get rid of one of the variables. But something really special happens. 5x minus 5x is 0, so that's gone, and 5x minus 5x is 0. So you're left with 10 equals 10. That does not mean the solution is 10. You are left with a statement that is true. This means the solution is all real numbers. No matter what number we put in here, it'll be true. For instance, I'm going to put in -3. And watch what happens. -3, so 5 times -3 plus 2. Oh, that's not the right thing. 5 times -3 plus 2 is -5. And then 5 times -3 plus 10 is -5. So notice, -3 is a solution. And no matter what number you put, every number in the world is going to work on this equation. So that means it's all real numbers. And sometimes you'll see this R, which means every number in the world is the solution. The last thing is some equations are never true and have no solution. So I want you to see this. If we have x plus 5 equals x plus 3, we're going to start to solve this and watch what happens. I have variables on both sides, so I would try to get rid of one of my x's. Now something special is happening again. This is gone and this is gone because they both equal 0, but we are left with 5 equals 3. That's not the same thing as saying 10 equals 10. That's true. 5 equals 3 is not true. So if this happens to you when you're solving, it means there's no solution. It doesn't matter what number you put in here. If I take a number like 10 and add 5 to it, and then I take that same number and add 3, well, of course, they're not going to be equal. It's not going to work for any number in the world. All right, so you're going to see that come up in our classwork today. Go ahead and turn the page. We are going to start solving inequalities. Inequalities are the ones with these little mouth signs, right? They're not equal signs. So we solve inequalities exactly like we do equations. Nothing's going to change except for one thing. The only difference is that we have to flip the sign, which is the inequality, if we divide or multiply by a negative. And I'm going to show you what that looks like. If I have negative 5x is less than or equal to 25, I would draw my river, and these are being multiplied, so I know that I have to undo that with division. I'm going to divide by -5, and I get 1x, but because I divided by a negative, this inequality flips the other way. It was less than, now it's greater than or equal to, oops, wrong answer. Let me erase that. 1x is greater than or equal to 25 divided by -5 is -5. So this is your solution. Okay, so now we're going to move on, but I'm going to need you to pause the video, and there's going to be another video that shows you how to solve this. So you will find the other video. It's listed on your front page. It shows you the names of both of the videos.